All right. Well, hello and welcome to another exciting episode of Fun with Physics. This is your host, Mr. Easley. We're looking here at EC9. This is part three. Specifically, we're going to start with question EC9Q4. I don't know that you have to be even know where this question is for what I'm showing you to be relevant. But what it basically says is, and this is I've started drawing the circuit right here. What we know starting out is it says that two resistors are connected in series to a battery. Their resistances are 1 ohm and 5.7 ohms. So I can go ahead and write that down. I can say 1.0 ohms, 5.7 ohms. This is a given. It says the current in the circuit equals 2.6 amps. So current equals 2.6 amps. This is the given. This is where we start. What it wants to know, ultimately, what is the question, is what is the voltage drop across here? And what is the voltage drop across here, across each of the resistors? Now, where on earth does start? And this is where it's going to start getting a little difficult because we have to start doing a little bit of thinking. And one of our main things to go back to is going to always be Ohm's law. If you're not sure where to start, Ohm's law is a great start. And so we do have a current. We'll go ahead and write down Ohm's law. We do already have a current. And do we have resistance? Well, sort of. We have two separate resistors here. We do need to realize that these can be easily added together to get total resistance. So let's go ahead and do that. All right, so I went ahead and wrote this down, but if we remember, in a series circuit, when resistors are in series, the equation for resistance total is this. So these resistors would just add up. So we have a resistance of 1 ohm plus a resistance of 5.7 ohms. And so our total resistance in this entire circuit is going to be 6.7 ohms. So we can use that over here and jump in there then and say voltage equals current 2.6. Since it's amps, we're going to leave units out just to make this more simple. And then 6.7 ohms. SI units in, SI units out. The product of this is going to be the number of volts we have. And so there we have it. Our voltage on this is going to be equal to 17.42 volts. And what that tells us is this battery here is increasing our voltage, is going up by 17.42 volts. That's going up. Now what we know then is as it goes around here, this voltage has to get subtracted away, and it's going to be subtracted proportionate to its resistance. Now we may not even need to know this in the long run to tell what's across here, but I like getting this number here because that's going to be a great check for what we're doing. But in this case, then if we look at each one of these, we can use Ohm's law again. And again, technically you may not have had to do this. It's a great starting point because this is a good check for us. But if we look at each one of these scenarios, we can run it through the exact same equation, solving for voltage across there. And we can say, for this one right here, we can say voltage is going to equal current times resistance. So voltage there would equal your current of 2.6 times 5.7. And that's going to be at that point. We could do the same thing over here for this one. So we have voltage Let's change the color. Voltage. .6. Remember, the current is the same throughout the system since it's in series. Times 1. Shouldn't need a calculator for that. 2.6 volts. So the voltage there is going to be 2.6 volts. Now we really want to add these up to make sure we're right because of Kirchhoff's loop rule plus 2.6. Hopefully we'll get that number we have. We have 7.42. Yes, that adds up to 7.42, so we are in great shape. So we have our answers there for both of those. And we could say the voltage drop across each one of them, the 1 ohm resistor and then also the 5.7 ohm resistor. Some of the other questions on this EC9 will say things like, if you have this circuit and you can't read this, I'm just going to write these down what they are. It says if these three resistors are 1.69, 5.10, and 2.06 ohms, all of those, move that over. We can look at this and it says, what is that total resistance? And that's where we go back to our equation, and I'll write it. We go back to this equation here. Since these are in series, remember, resistors add up like this, so we could put in the things we know, 1.69, 5.10, and then 2.06. We could add all these up to find that total resistance. Obviously, for time's sake, I'm not really going to do that because I think you probably can do that on your own, but that is how these would be done. Thank you. Make sure to like and subscribe.